Okay, so thanks everyone for being here, and thanks Damien for giving intro to where we are on OCP NIC 3.0. For a number of us, this has been several years of intense work in the community, and I'm glad to see we are past that chasm part, and we are now into the volume deployment, and we are talking about now the enhancements. So in this session, what John and I will cover a little intro. I'm distinguished engineer at Broadcom, and I also co-lead the hardware management project. John is our senior distinguished engineer from Dell, as well as he has been very active in OCP subgroup, so am I. So there are a number of people I see faces here. This is community effort that has come to fruition. And in this talk, what we'll do is, first, I'll summarize the 1.0 spec features, and then summarize what enhancement went into the 1.2 minor update. And then I'll hand it to John, who has some detailed slide on some of the specific 1.2 enhancements that he'll cover. Okay, so this is what it took to go from chasm to reality, but you can see community had done several workshops over more than 5 years. We have all come together. There are a lot of contributions, came from 16 companies originally, but then the community expanded. We have a number of implementations that are out there. Pretty much this OCP NIC 3.0 project, if you see from 2018 to now, within last 5 years, it has become very successful in the server ecosystem. So this is the highlight, how the community has evolved. Let me spend some time on so when we started the baseline spec, the idea was to focus on some of the key functionality. So we initially started in 1.0 with small form factor and large form factor. All the mechanical, electrical aspects of those two form factors were defined. Also, we paid a lot of attention to debugging aspect. So the scan chain interface, the interface we had on both primary and secondary connector. Primary connector had USB 2. So this is something we were also talking about. This kind of interface we can leverage down the road also for sideband interface. And then UART was for secondary connector. And then 1.0 focus on PCI Gen 4, and you will see between for small form factor by 16 and large form factor by 32. So it allows you to have up to Gen 4 by 16 or Gen 4 by 32 kind of devices. Other thing we paid a lot of attention to is the shared NIC model. And what I mean by that is going forward, either within a system, you are seeing multiple root complexes connecting to the same NIC. This could be NUMA type of architecture, or there are other architecture where you have independent nodes sharing the same NIC, and they are all connecting via PCIe. So that's why PCIe bifurcation becomes very important. And if you look at the spec, we spend tremendous amount of time really defining that and the protocol between the baseboard and NIC to also allow dynamic kind of detection of PCIe bifurcation. So this will help all the single root, multi-root, multi-host kind of scenarios, and that has been the case. There are implementations of OCP NIC 3.0. They support all this different configuration. So that was a lot of attention paid to that. And then there are some things they may be obvious, but they were important to us, like numbering the ports, getting to the common labeling kind of requirements. Power state really simplified, but defined clear power sequence so that from system standpoint, the implementers as well as the system vendors can count on that, and during the different transitions, they can really rely on NIC being compliant to the spec. So that basically created the whole baseline set of features. And from day one, we looked at this device and have talked tomorrow where I'll go over, but we had a template when we started OCP NIC 3.0 that we want to make sure that all the baseline manageability and the security aspects of the device, they're clearly specified based on the standards that we want to leverage. So we paid a lot of attention to that. And the spec clearly defines what sideband interfaces are supported, or those sideband interfaces, what transports that need to be supported. That's where RMII and SMBus, those two physical interfaces, come into picture. And then the transports that are based on RBT, which is RMII-based transport defined by DMTF NCSI spec, which is a derivative of RMII. And then MCTP, which has become very, it's basically, I look at that as your within platform management subsystem, that's your TCP IP. But it's very lightweight, all components can implement. It enables this communication between those components. So OCP NIC 3.0 leverage those. And on top of that, some of the key features that you need for like NIC operational management, whether they're related to inventory, temperature control, power, measurement, all firmware-related inventory, firmware update, has to be secure firmware update. And those interfaces, once you have one common way to do that, what it does is in the ecosystem, a BMC vendor can count on if a NIC that is compliant to OCP NIC 3.0, how they can manage it using a standard set of features. So there is nothing proprietary in there. And this allows them to add more intelligence on top of those kind of baseline device management. So that was one of the key aspects. For the security aspect, secure boot, secure firmware update is specified as a must-have for the device. Also, we follow the NIST guideline. So NIST has this spec where it clearly states for security what they expect from the device standpoint in terms of booting, the firmware, and we paid a lot of attention to that. So that's part of 1.0 baseline spec. So this was the base that we started with. And over the last couple of years, we have enhanced that further, and that's what Damien was talking about. We will spend the rest of the time on that. So these are, you can think about this, these are some feature enhancements. So TSFF, which basically allows you to have more heat dissipation, still using SFF kind of form factor. And then basically it's increasing the Z height. You'll see on next slide. John will go into a little bit more detail on PCI Gen 5 and what we are doing to also enable the community. There are a couple of modules related enhancement made. This is where the OSFP, RHS, and QSFP DD that was added in 1.2. And while doing that, we also went over the whole spec and looked at what are the other things where we got over the last couple of years before 1.2 feedback on the requirement clarifications, especially around bifurcation, RBT. We also added safety requirements. The power down sequence and the whole power state transition was further enhanced. And there was one of the other things we did while doing that is we do allow in this 1.2 version, you can directly go from ID mode to main power mode. So those are some of the key enhancements and new features that were added to 1.2. With that, let me hand it to John to go over some of those in more details.
Thanks, Hemal. So some of what you're going to see, Damien showed a little earlier. But first, the tall, small form factor. This is an interesting development. It was adding about 2.7 millimeters to the top side Z height. And the reason for this is the original small form factor was designed for a height where you could stack it with a PCIe adapter. The tall small form factor is a double stacked tall small form factor. So we took that additional height and gave a significant thermal advantage. We don't have the data here today. We shared it in the in the work group, so those notes are there. But it's very significant in what you can do if you just allow that heat sink to change from a small form factor to a TSFF. You saw a picture of the thermal test fixture. We do have the parts to convert from the standard SFF to the TSFF. And the good news is fairly shortly we're going to announce a place that the community can go purchase those for the design that was contributed. So PCIe Gen 5, we have all 32 lanes, both TX and RX. It's 32 gigatransfers per second. It was challenging. We do have that support working on the thermal test fixture. When we get that released, we'll be presenting in the NIC subgroup from one of the Dell folks. We still have all of the features that you have in the small form factor. You still have the ability for 4 hosts. You have 4 sets of discrete signals. You have all the lane bifurcation, quite a few of them. And we also gave the system back some of the SI insertion loss budget. And so where PCI spec, I believe, is 9.5 dB loss, the SFF is only required to take 7. Now the LFF does follow the PCI SIG chem standard. So where are we as far as test fixtures? Thanks to Meta, they brought some of the test fixtures that we had done for Gen 4. The Gen 5 test fixtures are in test. The second version of the board has a small fab board problem. We're working with the manufacturer to try to find root cause before we build more of those. They are fairly expensive. And that's for the load board. The CBB is ready to fab out, but we're trying to make sure that we don't have the same fab board problem with the CBB that we have with the CLB. Those will be on the UNH-IOL site as soon as they're ready. And please contact them. It's out in the experience, the OCP NIC 3 Experience Center in the Expo Hall, and it does have their contact information as well. So, that's great. So we have these mechanical pieces. If you already have a thermal test fixture and you need these bits, they will be contributed officially probably by the December incubation committee meeting. The CLB, the CBB for the 32 gigatransfers will be contributed at the same time for the small form factor. The large form factor, as Damien has said, we don't have that many servers, if any, that have that, or boxes. We are still going to contribute the designs for the CBB and CLB for the large form factor. I do know of at least one current development for that, and so we want to go ahead and contribute that and support it. Hemal mentioned a couple of the pluggable I/O modules. I think that those enhancements were great. We were able to get to the 8 lanes. PCIe Gen 6, several companies have been working behind the scenes to enable this. There's still some technical challenges, but I'm excited at the progress they're making, and we're looking forward to delivering Gen 6 capability on the existing form factor. And then, of course, security. It's key. We have the self-shutdown, but one of the key things, as Hemal mentioned in the beginning and Damien mentioned in his presentation, is this is a community process. And, we've crossed the gap. We want more contributors. We want to expand where OCP NIC 3 is out of maybe the server into other things. It's a very unique form factor. One of the key attributes of it is that you can take an OCP NIC 3 designed for anyone and put it into a server that supports the OCP NIC. It's not customized, and it works. And we do that even at Dell. So it's a great form factor. That's made possible by the community and the 16 original companies, and then all the people that are implementing it and providing feedback. So, call to action. Flood Damien's email with comments about OCP NIC, right? I think that we have a few little, one of the things that really stands out is we're on spec 1.2, but if you look back, there have been very, very few corrections to the spec. They've all been enhancements. And I think that's a key tribute to the people that wrote the original spec and the diligence that was put into there. But if you do find some things, I've seen some really good comments coming out of people that have just picked up the spec for the first time on clarifications that we need to make. And we need to get those in there because I believe that the spec is solid, but we want those clarifications so that anyone can use it. And then come see the meetings, the subgroup meetings. They're on the OCP calendar. All the contributions are on the server MES 3.0 wiki site. There's a ton of information there. And then come participate and contribute to the OCP NIC 3. Questions?
Right. Yep. Questions?
Seems like you could almost yell and be heard.
Yes.
So 2 questions, and I don't know if you can actually address them because they're probably beyond where you're currently at. Looking at things, speeds and stuff, the whole transition towards OSFP and figuring out how to fit OSFP capable connector solutions in the NIC 3.0 seems to be one of the challenges that's out there still. And the second one is, are there any moves? Could you talk about that? But are there any moves also for looking at a wider version of the wide form factor? I've seen some discussions where many motherboards set up with dual single wides, and then if you ever try to map a double wide in, it's incompatible with board designs that already exist. And I don't know if you guys have that as something that you talk about. So I just kind of future, I don't know if you can talk about them.
So on the OSFP, we have as Hemal mentioned, we have the writing heatsink version in the spec today. That was contributed by one of our original 16. We are looking at what the future of optical and cable connections that needs to be, but we are limited, as Damien mentioned in his speech about when you use the 8-lane parts, the connector takes up a much larger space on the SFF than was originally anticipated. And by the time you get an ASIC capable of 400 or 800 gig, there's very, very little room left for VRs. And so it is likely going to take good miniaturization or a larger form factor, which is where Damien was saying, come contribute. Do we want to make it longer, or is LFF the right method? To your second point, when we originally did the specification and we were coming up for the width of the SFF and the LFF, the original thought was to make it 2 times an SFF. At the time, for the original companies contributing and checking their mechanicals, no one could support the width of 2 SFFs. And so it was shrunk to where we could actually make it fit in the servers at that time. Hindsight, maybe it could be that width, but that's where we are today. We did create a prototype in that time frame that showed that yes, we had the fab board cut out where you could actually insert it and you could make a bracket that would change from the 2 single width SFFs to a LFF. But besides that, I don't believe there's any discussion about making it wider in the chassis. It's the depth that Damien had showed in his presentation is really what they're looking at.
I think that being said, just to add to what John was saying, if you have a use case for that, because the way we came to this form factor is we had people saying, okay, I have this one configuration where I have accelerator and 8 memory chips. I mean, they came up with those kind of configuration, and that helped us in deciding. So if there are things like that that you want to come and contribute and give community, like there are some use cases where having a wider dimension may help. So then we can look into it.
Right. No other questions? All right. Thank you very much.
Thank you, everyone.